The title of my research is Using Remote Sensing Imagery and Machine Learning to Predict Poaching in Wildlife Conservation Parks. Illegal wildlife poaching is driving the loss of biodiversity. Wildlife conservation parks around the world are trying to prevent illegal poaching by sending rangers to patrol the park and remove snares. However, with limited resources, these rangers cannot patrol the entire park. Thus, there is a need to optimize patrol routes for areas predicted to have highest poaching probability. The Protection Assistant for Wildlife Security, PAWS, was introduced as a machine learning approach to help rangers identify areas with highest poaching risk. As PAWS is deployed to parks around the world, we recognize that many parks had limited resources for data collection and therefore have scarce feature sets. To ensure under-resourced parks have access to meaningful poaching predictions, we introduced the use of publicly available remote sensing data from Google Earth Engine to extract features for parks. We incorporate previously unavailable dynamic data such as temperature and precipitation to enrich predictions. We discover we can recreate several features previously computed manually. Using only publicly available data, we achieve prediction performance comparable to predictions made using features computed manually. We create an automated pipeline that extracts remote sensing data from Google Earth Engine. We identified 13 features from Google Earth Engine as potentially useful for poaching predictions. We discretize the park boundary into 1 by 1 kilometer cells so we can later predict the risk of poaching in each of these cells. We crop and rasterize, or convert into pixels, each raw remote sensing image from Google Earth Engine into our desired 1 by 1 kilometer cells as well. For dynamic data and past patrol data, we discretize time into 3-month intervals to account for seasonal poaching predictions historically found. Here is an example of processed features extracted from Google Earth Engine in the first 2 rows, versus features provided by park specialists from Cross River National Park in Nigeria, seen in the bottom row. Notice that patterns in Google Earth Engine's flow accumulation in A are similar to the Parks River feature in L. Now that we've pre-processed our features from Google Earth Engine and from the shapefiles provided by park specialists, we can make predictions. Our labels are a binary indicator of past illegal activity. Note that past illegal activity data is invariably incomplete, as rangers can't possibly search the entire park. One of our key challenges, then, is to predict risk in areas not previously patrolled. To help adjust this uncertainty, we use I-WARE-E, an imperfect observation-aware ensemble model, which is a bagging ensemble of decision trees as weak learners, training each weak learner from different bins of input data based on current patrol effort. We evaluate prediction accuracies for each feature set consisting of only features provided by parks, only Google Earth Engine features, and all features, both park and Google Earth Engine features. Here is a table of our results showing the AUCs for poaching predictions on 3 national parks using each of the 3 feature sets. We find we achieve nearly the same AUCs using remote sensing imagery without any of the several customized features from parks. This has widespread implications because under-resourced parks without the means to create their own features can now benefit from our automated pipeline to extract features from publicly available satellite imagery to generate reliable predictions that can guide park rangers to efficiently search parks and remove snares, ultimately saving endangered species. This research was done in collaboration with researchers at Harvard University as well as several wildlife conservation societies. Thank you to the rangers who are doing critical work to protect wildlife on the ground.